today we're going to be talking about, we're going to be performing a vector review. So, imagine we have a vector. And we take a second vector. And we decide we want to add these two together. What that means for us is we take the first vector and we put the tail of the second on the head of the first. And we get a new vector. Which points from the first. And it's tail to tail. This resultant vector is actually the sum of this and the sum of this one. Well, if we label the first one as A, vector A with a vector sign, and vector B, vector C, would be equal to vector A plus vector B. And this is known as the resultant vector. When we're adding, we have to recall a couple different rules of algebra. So, addition is commutative, which means if we take some vector A plus some vector B, we can change the order. It's the same as B plus A. It's also associative, which means when we add three vectors or a large group, we can group them in any order, in any formation. To elaborate on that, like if we have some A vector plus B vector, and we want to do this first, or add it to another vector, C, it's the same as doing something like C vector plus B vector first, and then doing A after. So it's associative. Alright, and now we'll go ahead and take a look at subtraction. Some new vectors for the subtraction portion of this video. Call this guy vector A. And let's draw another one in red. And we'll call this guy vector B. Suppose that we would like to subtract these two vectors from one another. A minus B. So, what we would have to do in this case is change it to addition, basically. So, what we would do, because we know how to do addition, right? So, why learn something new when we can just do what we already know how to do? So, let's change this to A plus minus b. So what that means is this minus sign tells us to change the direction, because this vector is a vector that is the same as b, except it has a minus sign which changes its direction. So I'll go ahead and redraw A. Plus, which means put the tail of B on the head of A, and it's minus B, so it's in the other direction. I'll draw it like this, even though it would be longer. I've kind of boxed myself in at this point, and I guess I'll put the minus sign in, just to indicate that this is minus B, which is the opposite of this particular vector B right over here. So now the resultant vector points from this, or rather I should say from here to here, because we can tell by the tips of the arrows which direction they'll sum up into. I guess I sort of lied about this lesson, since we didn't really learn subtraction. We just said, let's go ahead and change subtraction into addition, because we know how to do addition. Okay, so now we should probably go over some more rules, like multiplication. What multiplication does to a vector. Scalar multiplication, so let's say we have some scalar like 2, and we multiply it to the A vector. What this means, graphically, is if A's length is normally like this, the 2 scales it to being twice as long, so its magnitude is worth twice as much. If we were to put a minus sign here, we would have to put the arrow on the other side. Multiplication by scalar works probably just exactly how you think it would. So let's say if we have some scalar d, and we want to multiply that scalar to the sum of 2 vectors like a plus b. This is the same as distributing d inside here.